Okay, so in this last lab assignment, you're going to look at calculating some surface hydrologic derivatives from digital elevation model. So this is an example use case of digital elevation data. So we provided a couple files. One is a DEM. This is a 10-meter resolution DEM provided from the National Elevation Dataset, or NED, and then we also have a hillshade we created from it. We're going to use this as an opportunity to show you how to use ArcGIS Model Builder. So we provided a video here that explains how to use and set up ArcGIS Model Builder. So using ArcGIS Model Builder, you're going to go through the process of generating a tool that will take an input DEM and then derive synthetic stream network and watershed boundaries. So again, here's some background information, and here's kind of your general workflow in Model Builder. Okay, so here's what your model is going to end up looking like, something along these lines. So you're going to have an input DEM, which will be filled or hydrologically corrected. That will then get fed into a flow direction tool. Then the flow direction gets input into a flow accumulation. You'll set a threshold to differentiate stream and not stream pixels. You'll turn the zeros into null, so you just have ones representing streams and no data for everything else. You'll create a stream link surface from the flow direction and stream layer, and then you're going to export that as polylines. And then you're going to combine your flow direction and your stream link data to create watershed boundaries. You'd like for someone who would use this tool not to have to interact with the model, but to be able to use it like they would use any other tool in ArcGIS Pro. So to accomplish that, you're going to turn this into a tool by setting parameters, renaming things, and making a nice clean tool. What you're going to deliver for us is effectively just a toolbox that has your tool in it, and we're going to run your tool and make sure it works, and that it's clean and easy to follow in terms of using good names and whatnot for inputs and outputs and things. All right, so that's it. That's the last lab, surface hydrologic analysis, and that'll wrap up the lab component of the class.